Okay, our first presentation topic is on Bluetooth. So we'll be starting with the definitions of Bluetooth that will give an overview of the topic. So, Bluetooth is a form of data and voice communication done in wireless short range with wireless personal area network technology, which is transmitting and receiving using radio waves. So, what are radio waves? Radio waves are a type of energy that carries information through space without wires, having the longest wavelengths moving at the speed of light. And this connects to frequency hopping. Frequency hopping is a spectrum that transmits short packets at different frequencies across bandwidths at wide portions. There is a receiver near the signals that correlates and chooses the best signal for demodulation. In Bluetooth, there are piconets, and this is the Bluetooth network containing a primary node and 7 secondary nodes, where the secondary nodes can only communicate back to the primary node. They're also known as master and slave nodes. And these nodes receive and deliver messages, which takes us to scatternets. Scatternets are formed by multiple piconets, and secondary nodes of one piconet can access the primary node of another piconet, creating bridge nodes. This is how connections are made between networks via wireless devices. And this leads us to multiplexing. Multiplexing is sharing of bandwidth or medium where several signals from several sources are combined and transmitted over a single line, where sources share one link carrying channels of information, and there are as many lines out as there are in. So, in summary, in Bluetooth, the binary offset code sequence in frequency hopping is used, and it is how data is transmitted. It happens in breaks of data at different frequencies, so receivers can select the best signal for highest performance, even across noisy channels, because there are different slots at every signal, allowing for the strongest one to be chosen. When two devices start to share data, they form a network called Piconet, which is to accommodate more than 5 devices. And then from Piconets, there are scatternets, which enable larger network area and more devices to connect to each other over applications that are large hubs such as the internet. And multiplexing is used alongside scatternets. It provides channel sharing needed for devices to participate in multiple piconets and supports the creation of connected scatternets. So now we can look at Bluetooth's relevance to engineering.
Bluetooth is an incredibly useful technology for those who are involved in engineering design and those in the engineering practice. Not that long ago, if we wanted to connect devices, we would have had to connect them with either wires or cables, which take up a lot of valuable space. But now we can make these connections to devices without wires. Bluetooth also has a very low power consumption and very low costs, which makes it attractive as a designer compared to other communication technologies, such as Wi-Fi, radio, or HDMI. Bluetooth is also much more simple and user-friendly than these other technologies. However, one thing to take into account as a designer is the membership cost to use Bluetooth. For as a designer, you'll have to assess the trade-offs to determine if it's worth it to apply for the membership to use Bluetooth technology or not. Now, when an engineer decides to include Bluetooth in his or her design, the engineer has to decide what type of Bluetooth device he or she wants, since they can come in a variety of forms which vary based on their power output and range. Class 1 devices are the most long range and can reach up to 328 feet. They operate at a max transmission power of 100 milliwatts and would be useful if, let's say, you were designing a big warehouse facility and you need to design sensors which need to be connected from a long distance, and you would rather not use long cables or wires to do so. Class 1.5 has a more moderate range and maximum transmission power with a range of up to 98 feet, operating at 10 milliwatts. This class could be used if you were designing devices that need to be connected throughout a typical home or small office environment, such as maybe a smart home device or wireless audio device. Class 2 devices are the most common class used and have a range of up to 33 feet with a max transmission power of 2.5 milliwatts, and are commonly used for engineers designing devices which connect to people's personal devices, such as headphones or earbuds, stuff like that. Classes 3 and 4 are the last two types of Bluetooth devices, where Class 3 are even more short range and use even less power, only reaching about 3 feet at 1 milliwatt, while Class 4 is also very short range, with only 1.5 feet at half a milliwatt. These are less commonly used in engineering design, but could be useful if you need to design a device that needs to be extremely low power and only needs to connect at a very, very short range. Now, as an engineer designing a device that uses Bluetooth, one would need to assess how far the device needs to be connected and how energy efficient it would need to be in order to identify which of these classes of Bluetooth you would want to use in your design. Now that we have covered how Bluetooth is relevant to engineering design and practice, it is time to look at some more practical applications of these technologies and how they impact our society today.
Bluetooth technology can be used in a variety of ways when a wired connection is not available. One of the most common applications of Bluetooth is when you're trying to connect a wireless device to produce output. An example of this is when you're trying to connect a Bluetooth wireless headphone to your smartphone so you can hear the audio from your phone inside your headphones. Another common application of Bluetooth is using it to get a location of a certain destination or tracking a particular item. And then the next common application of Bluetooth is using it to collect data. An example of where this application can be used is in the medical field when the device collecting the information on the patient uses Bluetooth. Some of the impacts of Bluetooth on everyday life is making it easier for people to listen to music since Bluetooth is wireless. The less wires that a person has to use to listen to music, the easier it is to listen to music. Another way Bluetooth has made an impact on everyday life is making it safer for people to talk on the phone while driving. With Bluetooth, people can talk on the phone while driving without having their phone in their hand. This makes it less likely that someone will be distracted while driving. Now,
So Bluetooth has many challenges that are faced while it's being used. The first point that is mentioned is interference. While many Wi-Fi and other signal devices disturb the Bluetooth signal, this can cause slow data transfer and stuttering audio. A solution to this is by reducing congested channels and turning off any devices not being used. Another point mentioned in the slide regarding issues found in Bluetooth is latency. This relates to a time delay from when the device is sending audio to the output device receiving it. For example, using your headphones to listen to a movie on your phone and noticing the audio is not in sync with the lip reading of the characters. To reduce this, paired device should be kept closed and unused devices that are probably interfering with the connection should be turned off. Lastly, these issues are likely to occur in crowded office spaces or classrooms where there's a lot of devices that are likely to cause interference. With their connections, other public areas include cafes and airports as well. It's not possible to have all these devices in those areas to be turned off, but it's worth being mindful that those technical issues can occur with Bluetooth in those environments. Now we can turn to consider challenges and opportunities encountered. Mainly focusing on the opportunities, some benefits gained from using Bluetooth is having low power consumption. Cost effective, it's very cost effective and secure and has secure connections. The Bluetooth low energy, also known as BLE, is designed for long-lasting battery life. These devices are it mainly runs on low power mode and waits for a quick burst of data transmission. Such devices are fitness trackers, medical sensors, and smart home devices. This design is convenient for continual use. Another benefit is its cost effectiveness. The BLE is very cost effective because there is low power consumption and little external components needed. This helps supply chains by preventing more products to manufacture and healthcare clinics to allow a product that is very affordable, easier to access to checking vital signs. Last benefit is secure connections. The pairing process of Bluetooth includes exchanging encrypted keys to prevent data eavesdropping or man-in-the-middle attacks. This helps users feel safe and their data usage is protected. Now we can talk about the ethical issues that occur with Bluetooth.
One example of some ethical issues involving Bluetooth are the application of Bluetooth to make Bluetooth trackers like AirTags and Tile. These trackers have a security issue that they might be used by somebody to track somebody else without their knowledge. While AirTags, which are made by Apple, are not advertised as anti-theft devices, other trackers like Tile are advertised as anti-theft devices. The Electronic Frontier Foundation says it's impossible to make an anti-theft device that does not alert the thief that they are being tracked without also making a perfect tool for stalking. Apple has made some features to reduce the risk of this. They used to have it so that after being with somebody for 3 days and out of the range of the phone that it's paired to, it would alert someone with a sound, but the sound was easy to muffle, and the 3-day waiting period made it not very practical. It didn't really protect people's privacy. Tile tried to implement something similar, but they also implemented a feature that puts it into an anti-theft mode that basically just disables that feature to protect people's privacy, to protect people from stalking. The Internet Engineering Task Force called together a number of parties, Apple and Android included, and also the EFF, to draft the detection of unwanted location trackers specification. And in that, they were able to agree on some standards. Among these standards, they included the proprietary payload, which allows individual vendors to include a proprietary payload that may be different between each of them. And this is where they would implement their manufacturer-specific encryption. However, this could lead to industry fracture. And now for some questions to the audience. Why might some devices be limited to one connection? What's the origin of the Bluetooth logo and name? What advancements can be made in Bluetooth? What are some industries that could benefit from an increased use of Bluetooth technology? And how could Bluetooth help in your senior design project?
The second presentation topic we will talk about today is alternative energy. Now we will talk about some definitions and overview for alternative energy. So alternative energy is energy that's created from renewable resources. A renewable resource is anything that can be reused or replenished over and over again without it going away. Some examples of what can be considered as alternative energy is solar energy, wind energy, and hydroelectric energy. Solar energy is energy that comes from sunlight, and this type of energy is mostly captured by using solar panels. Wind energy is energy that's created from the wind and is captured by wind turbines. Hydroelectric energy is energy that's created from water, and this type of energy is usually captured using dams. Now, why is alternative energy a better option than non-renewable energy? One of the main reasons why alternative energy is a great alternative to energy that comes from non-renewable resources is because alternative energy produces less harmful chemicals for the environment compared to non-renewable resources such as fossil fuels. Another reason why alternative energy is a great alternative to energy that comes from non-renewable resources is because it's available all over the world, so there won't be an issue of alternative energy running low or running out. And then another reason why alternative energy is a great alternative to energy that comes from non-renewable resources is because renewable energy tends to be cheaper than non-renewable resources. Now, what resources are good to look at to learn more about alternative energy? One of the most useful resources to learn more about alternative energy is energy.gov, also known as U.S. Department of Energy website. On this website, there's a lot of resources that gives readers a better understanding of what alternative energy or renewable energy is. Also on this website, they try to answer questions that people may have about renewable energy or alternative energy. Another useful resource to learn about alternative energy is the United Nations website that has helpful information to learn more about the benefits of alternative energy. Now we'll transition to the relevance to engineering design and practices.
Alternative energy is an extremely relevant topic when it comes to engineering design and practice. As engineers, we are always trying to figure out how to do things more productively, at less cost, and in a way that makes the world around us a better place. When it comes to producing energy, fossil fuels are a common way to do so, but these have many harmful effects on the environment, and these resources are limited and may eventually be depleted. Therefore, it is up to engineers like us to design alternative energy sources like solar panels, wind turbines, hydroelectric generators, and other such systems. When it comes to such sources of energy, a main part of the engineering design of such systems comes down to assessing the best locations for such systems of energy and what types of systems may be best to use in a given location. In order to do so, we first need to know the energy requirements for the building or for the area which the energy source is that will be generating energy for. This includes patterns in energy consumption, such as what times are the peak load of a building or an area, in order to know how much energy we're going to need. Once this is analyzed, one will be able to better determine what type of renewable energy source would be best to design in a given area. Not only this, but an engineer wanting to design a renewable energy source needs to know the characteristics of the location to know which type of energy source would be best to use. For example, as an engineer in Florida, one would most likely want to focus on using solar panels, since in Florida we get so much sunshine. While in states in the Midwest, such as Iowa, who have very, very flat terrain and lots of wind, it would clearly be more beneficial to focus on wind turbines as a source of alternative energy. However, as a part of engineering design, one must take into account the various trade-offs which may occur with different sources of alternative energy, such as the high initial cost of such energy sources like solar panels or wind turbines, and the effects which such alternative energy sources can have on the environment. For while installing solar panels may not be releasing the same fumes into the atmosphere as fossil fuels, which is good for the environment, that's good for the environment that they're not releasing the fumes, these solar panels or wind turbines may be more expensive to install and also may require the removal of trees and other such natural organisms, which is not good for the environment. In addition, such sources of energy may not always be reliable, since the sun may not always be shining or it may not always be windy. Physical limitations of an area also play a role, for adequate space is needed for the system an engineer is trying to design. In addition, if one is designing an energy source for a building, then the engineer designing the system would need to take into account the building orientation and other characteristics which may influence the amount of sun or wind the energy system receives, and therefore how much energy the system will produce. All of these factors must be taken into account when engineers are designing alternative energy systems. Now that we have covered how alternative energy is relevant to engineering design and practice, it is time to look at some of the more practical applications of these technologies and how they impact the society around us.
So, the applications we'll look at are wind energy, solar energy, geothermal energy, and hydropower energy, starting with a small recap and then how it applies. So, looking at wind energy is applied by wind turbines located onshore or offshore, which converts kinetic wind power into electricity. There are land-based or offshore wind farms that have a large number of turbines together, generating large quantities of electricity. Wind energy is also applied to transportation or in wind pumps to extract water from underground. And in its simplest form, not having to produce electricity, wind energy, which it's kinetic energy, is used in sports like windsurfing. Our next one is solar energy, and it is applied by panels of photovoltaic cells that collect the energy from the sun and converts UV rays into electricity. There are solar farms that have large numbers of panels over acres of land to collect energy in abundance. Solar energy itself can be used to heat water, allowing the sun to do so directly, power transportation, provide shade to crops while collecting energy and generate power, and process conversion of salt water to fresh water in desalination plants. Next is geothermal energy, which is applied by extracting hot water or steam from underground to rotate turbines and generators that convert this thermal energy into electricity. There are power plants that collect this energy, such as dry steam, flash steam, and binary cycle power plants, even power energy with this collected energy. Geothermal energy itself is used in food dehydration, gold mining, and more commonly, milk pasteurization. It can also be seen in simpler forms as heating homes, drying crops, spas, and greenhouses. Last, we have hydropower energy, which is applied by the use of stored water being released at high speeds into turbines that propel generators and convert kinetic energy of water into electricity. There are reservoirs and large dams. Commonly, we know the Hoover Dam, and they're at hydropower plants that convert moving water into power, which supplies energy to applications such as hydraulic systems that support irrigations, water pumping, and flood control. It's also used for processing clean drinking water. So, as a quick recap, wind energy uses turbines that turn wind energy, which is kinetic energy, and it's connected to generators, which starts our process of converting this energy into electricity and power. It's used in transportation and wind pumps for extracting water. Then solar energy, which is the collection of UV rays by photovoltaic cells, commonly known on your solar panels, which can store or convert to electricity via inverters. They're seen in transportation as well in agricultural settings, such as shading crops for intense heat, while still collecting energy also in desalination plants. Then geothermal, which is the process that starts miles and miles underground, where hot water or steam is extracted and used to turn turbines, similar to wind turbines, rotating in generators that convert this energy into electricity and power. They're used in different plants. There's many different geothermal plants, and the way that they differ is just how it's collected, whether it's steam alone, all underground, hot water alone, or a hybrid of these. And geothermal energy is used in milk pasteurization or food dehydration. And then there's hydropower energy, which is similar to wind and geothermal as it uses the kinetic energy of moving water, yet again, kinetic energy, on turbines, which connects to generators, which converts this energy into electricity. And it's seen in things like flood control or to clean drinking water. Now, these applications have led to many impacts that we can look at next. One of the first impacts is the use of alternative energy being a cost-saving substitute for technological systems as it demands less for maintenance and operating costs. To be specific, there is no refueling costs when the energy is being gathered and converted from natural resources such as the wind, sun, steam, or water. And these are all resources that are in abundance or at free use on collection or conversion. Since these are natural resources, they require no maintenance on their gathering or assembly. Next, alternative energy is a substitute option for traditional fuel sources and natural gases in order to avoid greenhouse gas emissions that leave large carbon footprints and intensify climate change. Using the wind, sun, steam, and water, it decreases the amount of pollutants entering the atmosphere as they are gathered and don't contribute to the respiratory or cardiac related issues from the underlying effect that traditional sources of energy implement on our society. Last, expanding on the use of alternative energy means there are more industries for each source, whether that's wind energy, solar energy, geothermal, or hydropower, that would they all generate new and demanding jobs, which creates a positive boom in economic growth. Not only will it create jobs, but these jobs will more than likely be paying above the minimal and average wages, which expand on the amount of increasing opportunities that can be provided. Renewable energy offers 3 times the amount of job offers that fossil fuels would. Next, we can look at how and where alternative energy encounters its issues.
So when looking at how and where alternative energy encounters issues, we can think about how alternative energy is growing and evolving. And while becoming increasingly popular, there are challenges that they face, as listed: intermittency, storage limitation, environmental impact. One challenge that we can talk about is intermittency. This is fluctuating output from an alternative energy source. For example, solar power can only generate electricity only while the sun is shining. Solutions to this problem is developing energy storage systems and/or creating a system using multiple renewable energy sources simultaneously. Another challenge that is faced is the environmental impact. While using renewable energy sources can reduce the carbon emissions, it does have its environmental impacts. For example, hydropower alters river habitats and block migration routes for aquatic animals. Also, dams prevent sediment from flowing downstream, affecting ecosystems. With this challenge occurring, sites to build power plants are carefully selected. Also, there's plenty of room to innovate a system that solves both issues. Some opportunities. Now we can move over to the next slide, which talks about the challenges and opportunities encountered. Just focusing on the opportunities, there's job creation from these renewable energies power plants, rural development, and public health benefits. The Department of Energy government site estimated around 3.5 million jobs are active in the renewable energy field. And there's a noticeable growth of 18% from 2022 to 2023. Another opportunity found is that there's lower energy costs in rural areas and jobs created. Also, there's a lot of resilience coming from using renewable energy sources, since when experiencing the aftermath of an extreme weather event, providing more stable power. Lastly, the benefit comes from public health, with fewer respiratory or cardiovascular diseases due to cleaner air from sources such as wind power. Now we can consider the ethical issues that are involved from using alternative energy.
Alternative energy requires the use of batteries like lithium-ion batteries for storing energy. These are used both for the grid and also for devices that get electric power. However, the process of mining cobalt for use in these batteries can yield some ethical issues. For example, in the Democratic Republic of Congo, there is about half of the world's supply of cobalt there. And so it's really a hotspot for mining cobalt. But in the Congo, there are little to no protective measures being made. So people don't have a lot of protective gear, often won't have shoes, and use burlap sacks tied together in place of ropes in the mines. And also, it's not uncommon for child labor to be used in the mines. These pose some real safety concerns and ethical concerns for the mining of cobalt for use in these batteries. Also, there are impacts to local communities that may not be positive when it comes to creating farms or plants for alternative energy production. Often, communities that are already vulnerable, like indigenous communities or rural communities, are the most at risk for this, as their sacred or agricultural lands are used for these projects, even when the communities themselves don't want them to be used for this. The creation of these farms or plants can create strain on local resources during the construction, as people are brought in from outside the community with the specialized knowledge needed to construct the farms. Job and economic growth isn't guaranteed for the local communities, as the jobs that are created may require specialized labor that will just end up employing people who aren't already living in the communities. Also, there's a possibility of noise pollution and property values going down, For example, with windmills, they make some noise that can reduce property values. Also, when these farms are operational, the economic growth may not go to local communities. It may go to investors who don't live in these communities. There are also some environmental impacts like deforestation, habitat loss, and soil erosion that are results of creating these farms, like clearing space. Hydropower can also alter river flows and disrupt aquatic ecosystems. And now we'll look at some questions to the audience. What are some other potential sources of alternative energy? Is it costly to store alternative energy? How could the negative effects of alternative energy be minimized? Do you think alternative energy could completely replace fossil fuels? And what might alternative energy look like in a few decades?
In the making of these presentations, we use Microsoft Teams as that was our primary channel of communication. And why did we use it? We used it because it is a platform which is extensively used in the work environment, and as such is beneficial for us to learn how to use, since it can help us in our future jobs and lives. And how did it help? Obviously, first of all, it helped with virtual team meetings, which we had, and helped us to schedule things, our due dates, and help us to organize the project and our research timeline. It also enables us, it has a chat feature which we were able to use. And lastly, we also were able to use Microsoft Teams to help us in recording these final presentations, which was very beneficial. And that concludes our presentation. Thank you very much.